Assalamualaikum and good morning. I'm AFHAM Bmma AMRAN, and today we're going to present about the steering system steer-by-wire for the assignment vehicle dynamic. So our group member consists of 5 members. That is me, AFHAM Bmma AMRAN, Imran Alif bin AYUB, Jamal bin Abdul Gani, and Gani anak Liman. For introduction, a steer-by-wire system is a type of automotive steering system in which the traditional mechanical linkage between the steering wheel and the vehicle's front wheels are replaced by electronic signals and actuators. In a steer-by-wire system, the driver inputs commands to turn the front wheels by turning the steering wheels, which send an electronic signal to a computer. The computer then sends a signal to actuator, which are located at the front wheels and are responsible for turning the wheels. The advantage of a steer-by-wire system is that it allows for greater flexibility in the design of the vehicle interior, as there is no need to accommodate a mechanical steering column. It also allows for possibility of implementing advanced driver assistance system and autonomous driving capabilities. Literature review. So this is our list of article. First, we have research on steering control performance of electric forklift. Next, we have active fault tolerant control of rotation angle sensor in steer-by-wire system based on objective constraint fault estimator. Third, we have a hysteresis-based steering field model for steer-by-wire system. Finally, we have robust composite nonlinear feedback for nonlinear steer-by-wire vehicles your control. For discussion, our first journal is research on steering control performance of electric forklift with steer-by-wire. So for the methodology, our first methodology is a forklift steer-by-wire system. So steer-by-wire system reduce driver's operations difficulty. Different than the traditional mechanical control system that depends completely on the driver skill when the car is unstable. Limitation of mechanical structure also makes the available adjustment technology limited. Next, steer-by-wire control strategy. The steering control algorithm in the main controller will execute a compensation control on the steering motor to make the forklift body stable when the forklift deviates from the usual motion state as the result of a sudden situation. As for the result, the first one is particle swarm optimization, PSO. So PSO algorithm converge faster, but the fitness value after stability was slightly larger. Convergence of genetic algorithm, GA, was the slowest, but the fitness value after stability was slightly smaller than the PSO algorithm and close to the improved PSO algorithm. Convergence speed of the improved PSO algorithm was close to the PSO algorithm, and the fitness value after stability was the smallest. Finally, our result is side slip angle. The absolute value of the side slip angle under the GA was the largest after the convergence to stability. The absolute value of the side slip angle under the PSO algorithm was stable at 0. And finally, the absolute value of the side slip angle under the improved PSO algorithm was between the GA and PSO algorithm. Next.
Journal 2. Active fault-tolerant control of rotation angle sensor in steer-by-wire system based on multi-objective constraint fault estimator. Methodology. Number 1. Fault observer design. An SBW system model with parameter perturbation and sensor failure is established, and a multi-objective HI fault observer is designed based on the established model. Number 2. Fault estimator design. Based on the residuals obtained by the fault observer. A fault estimator is designed using bounded real lemma and regional pole configuration to estimate the amplitude and time varying characteristic of the faulty sensor, and the existence condition of the fault estimation observer is given. Number 3. Fault tolerant algorithm. A fault tolerant algorithm is designed based on the sensor fault estimate and fault output. Finally, numerical analysis is carried out to verify the proposed method. Result: estimation accuracy of the fault estimator. The analyzed result validated that the design fault observer can accurately and timely diagnose the faults of the sensors of the SBW system. When different types of fault occur in the sensors of the SBW system, the design MCFE can accurately estimate the sensor fault size and time varying characteristic and is robust to parameter perturbation. And the fault tolerant control strategy can make the SBW system with sensors faulty close to the faultless SBW system. Moreover, the steering characteristic of the system can meet the basic requirements of the wire control system, in which the feasibility and effectiveness are fully verified while applying the active fault tolerant control framework to the SBW system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Jamal bin Abdul Gani. Metric number B09201025 Our third journal is a hysteresis-based steering wheel model for steer-by-wire system. Methodology. First, HIL simulation system. In the HIL simulation environment, a hardware under test is substituted for its mathematical model in a simulation model of the whole system, and an interface between the physical system and the mathematical model representing rest of the vehicle is designed. Second, with test. The open loop test procedure requires the steering wheel to be subjected to an oscillatory input. The effect of different steering wheel models on the driver can be evaluated in terms of physical workload, which describe the physical work done by the driver in turning the steering wheel. Third, double lane chain test, a test scenario based on the ISO 3888I standard has been created to test the performance of a hysteresis-based model in a severe lane change maneuver. This test is used to investigate the transient road holding abilities of a vehicle. Result: effectiveness of the proposed steering wheel model. The results of the test have shown the effectiveness of the proposed steering wheel model. The hysteresis-based model can be designed more easily compared to other models due to its design flexibility in wider range and forms, since the steering-related motion of road wheels or their interaction with the road is reflected to the model indirectly. Even though the pneumatic trail is used in the model, this proposed model is not directly affected by the interference of active steering control commands. In conclusion, the research shows that the hysteresis-based steering wheel model provides a realistic and informative steering wheel to enable a comfortable and safe driving, and the model would be a useful tool by providing the flexibility and the ease of design and tuning.
Assalamualaikum. My name is IMRAN bin AYUB and my part is to the journal 4 about robust composite nonlinear feedback for nonlinear steer-by-wire vehicle, your control. The first one is about the methodology, the vehicle system model. The nonlinear model is used as the vehicle plan, while the linear model is utilized in the design of the controller. Considering the existence of a side-wind disturbance force, the governing equation of lateral, longitudinal, and yaw motion for a nonlinear vehicle system. Number 2 is front wheel system model. Consists of a steering wheel, motor rack, pinion, and front wheels. Third one is simulation setup. The performance of a robust CNF, which is a combination of a CNF and a DOB. With regard to a nonlinear vehicle system, can be evaluated in simulation using MATLAB or simulation software. The fourth one is hardware in loop setup. Hardware in loop, which is HIL platform, is built by using a MATLAB XPC target to validate the robustness of the CNF performance in real time. And for the result is number one is robustness analysis. The effectiveness of the robust CNF performance is verified through a robustness analysis. The front and rear corner stiffness of the vehicle model is varied to investigate the control robustness. The analysis is conducted in simulation using plus minus 20% of the nominal front and rear corner stiffness parameter values. And the last one for the result is simulation and experimental result. The performance analysis of the robust CNF controller in the yaw rate tracking control is carried out both in simulation and by experiment. In simulation, the control system is tested using linear and non-linear vehicle models for comparison purpose. Then the control system performance in the non-linear environment is validated using a real-time HIL test. And the conclusion is, as for conclusion, technology nowadays make people life easier and has been one of important things in lifestyle and education. With the technology advancing, automotive technology always has a development and innovation. One of the example is steering system, starting in 1951 under the name Hydra Guide, using mechanical system. But today we see a better system, which is steer-by-wire system. The system keep advancing to achieve a better and perfect system in order to gain flexible, accurate, and improving the vehicle handling experience. And that's all for me. And thank you from we 3BMS S1/1 Group F.